guys, so today we're looking at exercise 15.6. This is Pythagoras Theorem. By the end of today's lesson, we should be able to apply Pythagoras Theorem to a variety of situations. Okay, let's remind ourselves what Pythagoras Theorem is. Pythagoras discovered a very important relationship between the lengths of sides of a right angle triangle. He found that if you take the lengths of the two shortest sides of any right angle triangle and square them and add the answers together, you end up with the square of the longest side. Okay, let's remind ourselves of how we label a right angle triangle. In order to use Pythagoras Theorem, we need to be an expert at finding where the hypotenuse of a right angle triangle is. This is the longest side in a right angle triangle, and it is opposite the right angle. All right, let's look at how we can use Pythagoras Theorem. Pythagoras Theorem states that c squared is equal to a squared plus b squared, where c is our hypotenuse and a or b are the other sides. When we're doing these questions, we need to label our hypotenuse c and the other sides a and b. We'll substitute our numbers into our formula and carefully do the sum. What if we want to find a side that isn't the hypotenuse? Again, we follow the same steps. We label our triangle with c as the hypotenuse and a and b are the other sides. Call A the side that you want to find. In order to find the unknown side, our formula becomes a squared is equal to c squared minus b squared. This is just a different arrangement of the formula that is given in our log tables. So when we're looking for an unknown side that isn't the hypotenuse, just subtract b squared from both sides. The formula for Pythagoras Theorem is found on page 16 of your formula booklets. Let's look at an example question. So in this question, we want to find the hypotenuse. The first thing we do is label our sides. C is the unknown, A and B are the other sides. Then we use our formula, c squared is equal to a squared plus b squared. Let's put in the numbers to the formula. This gives us c squared is equal to 9 squared plus 11 squared. Let's solve this out. 9 squared becomes 81. 11 squared becomes 121. This leaves us with c squared is equal to 202. Now we want to find c, so we square root both sides of the equation. This gives us c as 14.2 centimetres. This is correct to 1 decimal place. Note, you can always check if your answer is right, because our answer should be longer than both of the other sides. The hypotenuse is the longest side, and therefore. Let's look at a more difficult example. We're told a 5-meter ladder rests against the side of a house. The foot of the ladder is 1.5 meters away from the house. How far up the side of the house does the ladder reach? At first glance, it's very hard to see Pythagoras' theorem in these types of situations. So, when you have a question like this, draw a picture. If it's tricky, draw a picky. Okay, let's see what we have. We have our ladder, which is 5 meters. We don't know the length of the wall, and we know the foot of the ladder is 1.5 meters away. Okay, let's try and solve this question. Let's label our sides. C is the hypotenuse, which is 5 meters. B is 1.5 meters. And A is the unknown side. We can see in this question that it's a right angle triangle, so we will use Pythagoras, but we want to find a side that is not the hypotenuse. So we use the formula A squared is equal to C squared minus B squared. Let's put in our numbers. This gives us A squared is equal to 5 squared minus 1.5 squared. Let's multiply this out. A squared equals 25 minus 2.25. This gives us A squared is equal to 22.75. We need to square root both sides to find A. A equals the square root of 22.75, and this gives us A as 4.77. This is correct to 2 decimals. Let's look at another example question. To prove that a triangle is or is not a right angle, we show that it does or does not satisfy Pythagoras theorem. In this example, example 3, we're asked to investigate if the following triangles are right angles. To do this, we will label our triangle first. Call the longest side C and the other two sides A and B. We will then substitute these values into Pythagoras theorem and see if the left-hand side equals the right-hand side. Let's have a go. C squared equals A squared plus B squared. To show its right angle or not, we will substitute our values into this formula. This gives us 15 squared equals 9 squared plus 12 squared. Let's multiply out the left-hand side and the right-hand side. 15 squared is equal to 225. In our calculator, 9 squared plus 12 squared also gives us 225. The left-hand side equals the right-hand side. This triangle satisfies Pythagoras theorem, and therefore it is a right-angled triangle. Let's try the second triangle. Again, we want to check to see whether it satisfies Pythagoras theorem to show if it is or is not a right angle. The first thing we do is label our sides. Remember, the longest side is always C, the hypotenuse. Our other sides are A and B. From here, we write down Pythagoras theorem. C squared equals A squared plus B squared. Let's substitute our values into our formula and see whether the left-hand side equals the right-hand side. This gives us 1.4 squared equals 0.6 squared plus 0.8 squared. Multiplying this out on the left-hand side and the right-hand side gives us 1.96 equals 1. Here, the left-hand side is not equal to the right-hand side. This equation does not satisfy Pythagoras theorem. Therefore, no, it is not a right angle triangle. Please pause this video and take down this example question. Let's look at what we mean by Pythagorean triples. These are sets of whole numbers of the sides of triangles that form right angle triangles. They satisfy the formula C squared equals A squared plus B squared. For example, 3, 4, and 5. These numbers are Pythagorean triples because they satisfy Pythagoras' theorem. If I substitute these values into Pythagoras' theorem, the left-hand side equals the right-hand side. Can you think of any other examples? Please pause the video and take down the first section on what a Pythagorean triple is and an example of a Pythagorean triple. Let's look at a harder example. This is the Junior Cert Higher Level question in 2014. Use the diagram on the right to calculate the value of x. Here it's telling you to write your answer in surd form. Remember, surd form simply means keeping your answer with a square root. Okay, we want to solve for x. The first thing we're going to do is label our triangle. C is our hypotenuse, A and B are the other sides. Let's write down our formula for Pythagoras' theorem. C squared equals A squared plus B squared. This gives us C squared equals 3 squared plus 3 squared. Here, C squared is equal to 18. To solve for C, we square root both sides of the equation. C is written in surd form. However, we can simplify this by placing into our calculator the square root of 18. This gives us 3 root 2. Our answer is in surd form. We have solved it correctly. Please pause this video and take down the example question. Please try part 2. Okay, now that you have tried part 2 by yourself, let's look at what the answer should have been. Use the diagram below to calculate the value of y and give your answer in surd form. The first thing we do with Pythagoras' theorem is label our triangle. Our longest side is C, our unknown side is A, and the other side is B. From here, we write down Pythagoras' theorem. In this case, we're looking for A. So we manipulate our formula to A squared equals C squared minus B squared. From here, I substitute my values into my formula. Y squared equals 3 squared minus 1 squared. Let's multiply this out. Y squared equals 8. To solve for y, we need to square root both sides of our equation. This gives us root 8. Let's simplify our surd by putting our value, root 8, into our calculator and pressing the equal sign. This gives us a value of 2 root 2. Please pause this video and check your answer. If you didn't get it correct, please write down the... Okay guys, now that we've gone through the examples, it's time for you to try some yourself. Please turn to page 250, exercise 15.6. Please complete questions 1, question 4, and question 6. Please note in question 6, we're told that the ladder slips down so that its base is now 190 centimetres away from the wall. In this question, we are given the base distance in centimetres, but every other distance in metres. The first thing that you should do in this question is convert your centimetre value into metres. We do this by dividing our answer by 100. Therefore, 190 centimetres changes it into 1.9 metres. Okay guys, best of luck with the questions, and if you have any questions at all,